Hello, everyone, and welcome to another OhioX virtual event. Today, we have another fascinating conversation around artificial intelligence, one of the biggest topics with any company, any technology executive out there. And today, we are talking Hybrid AI Unleashed, which is presented by FAIR, by Rackspace, our friends there making this one possible. And so today, we're going to be talking about mastering the future of scalable, flexible, and cost-effective AI workloads. My name is Chris Berry. I'm the president and CEO of OhioX. We are a statewide nonprofit technology association, and our work is hopefully connecting, promoting, and advocating for the growth of Ohio's tech sector. And so we do events and programs all across the state, and we've been doing more and more of these virtual webinars to hopefully help people learn, discover, and share some of the work that's happening in this space, which is moving so quickly. And as we look at enterprises, especially, there's an incredible thirst and knowledge for information and knowledge to help do AI at scale. And so we're talking hybrid AI unleashed. And so just really excited for you all to join us today. I'm going to hand it over to our friends at FAIR just in a second, but a bit of a run of show. We'll have our presentation, and in a second, when I stop with my introduction, I'm going to hop in the chat section. I'm going to put my name and my LinkedIn and where I'm talking to you all from today. We'd love if you could do the same as well, so we can get a sense of who all is out there. Throughout the conversation, please use that chat function to share questions or insights or anything you may want to discuss or talk about. We have some great experts that are doing some amazing AI work at FAIR, and just really excited to have them here today. And so I'm going to now turn it over to Ben Blanquera from the FAIR team, who has been our partner in this AI work all across the year. We've been working with Ben and the team at FAIR and Rackspace on everything from AI roundtables with senior enterprise technology leaders to these webinars and a lot more. And we're just really excited for you to be here for this conversation. Ben, I'd love to welcome you to the stage, turn it over to you, and just thank you for your friendship and partnership to help make this possible as we think about what is Ohio's AI opportunity. And it certainly starts with knowledge and sharing information like this. So welcome and thanks for being here.
Chris, thank you so much for the great intro, and once again we welcome the partnership and friendship with you in OhioX. As we've indicated, FAIR is Foundry for AI by Rackspace, and as we thought about AI and its sort of transformational opportunity for all industries, we said, you know what? Let's do something, make Ohio be a leader in this. And so that's why we started to work with you and OhioX. And our goal is to accelerate the rate of Gen AI adoption for value here in this region. You know what? It's been 2 years since, almost 2 years since ChatGPT has gone into production, as was released. And what we've seen is that there's a lot of POCs, but there's sort of been a sort of hesitancy and sort of challenge associated with how do you do this at scale. And what we're seeing is that, new challenges regarding data, AI models, compliance, scale, and costs really matter as you go to scale. And so what we're hoping today is to unpack some very sort of subtleties associated how enterprises and organizations can think about that, because ultimately POCs are great, but they don't create value. It's going into production that matters. So at this point, I'd like to introduce my colleague, Nirmal, who is Vice President and Chief Architect of AI at Rackspace. Nirmal, over to you.
Perfect. Thank you, Ben. Thanks for the intro. And great to be here. I've heard great things about OhioX, and I attended the first of the few webinars and looking forward to the next ones that are going to come up. Just a little bit about me while I bring this slide up here. I want to make sure I'm sharing.
You're all good. We can see it just fine.
Okay, perfect. So, Nirmal Ranganathan, as Ben mentioned, VP for AI. And so in my role, I do two things. One, help Rackspace internally. So within our enterprise IT, how do we approach AI solutions? And how do we integrate that with the business? And then part of that is determining the right platform for the right workload and that whole process of ROI, business valuation, etc. And then the second part is really taking that knowledge that we've gathered internally and helping customers with that same information. But today, we're going to touch on hybrid AI And as we kind of get through the next hour, 45 minutes or so, you really start to get a feel for what does that mean. If I were to just give a baseline example or baseline definition, hybrid AI is the ability to run your workloads on different form factors, whether that's a public cloud environment, whether that's an on-premise or private cloud environment, or on the edge. And as AI matures, you're going to see workloads that transcend each of those environments. And that's where it becomes incumbent on how do you start to look at these workloads and get ready for that future. So just a little bit of getting started here. Now, what you've seen the last 2 years is so the increase in consumption of the GPUs, and that is predominantly driven by AI. So you'll see that sort of the blue dots. That's where you're starting to level off on the performance of CPUs and the single thread nature of CPUs. Right about last decade is when GPU started to come into prevalence, but more from a graphics and gaming perspective. The industry has been able to take that and adopt that for AI workloads, because right now that's the most apt hardware infrastructure or chipsets. But you're starting to see an evolution of that in the coming years as well. So what you're seeing is that huge jump in trend where we're going from sort of 1.x, 1.5x yearly increments to you're looking at 10x yearly improvements in performance jumps. And that's why you see that 1000x over 10 years. So what is that fueling? Obviously, it's all the AI workloads that's fueling that demand. But the challenges are really that memory wall. A lot of it is memory bound rather than compute bound. Yes, compute is a limitation as well, but where we're starting to hit the ceiling is on the memory front. As we build larger and larger generative AI models or foundational models, we talk about 70 billion parameters, 400 billion parameters. We'll probably get into the trillion parameter models. And the key requirement that is a lot of memory. And oftentimes how that comes into play is basically integrating a bunch of systems together and having high-speed memory interconnects that really help stand up and host these models. Now, if you break down the AI capabilities, there's two types of workloads at the very basic level. You've got your traditional AI/ML workloads, again, your regression classification models as examples, where you're building these models based on structured, curated input data. You're building, training these models, and then deploying them for inferencing. You've got the new class of AI workloads, broadly categorizing as the generative AI workloads. And that includes anything to do with large language models, so all the natural language processing, and also if you get to that one layer below, foundational models, applying that generation capabilities across a different other form factors, right? So it's not just text anymore, but image generation. And when you get into the multimodal nature, being able to understand and comprehend all types of information that is not structured, right? So unstructured information to be able to comprehend and process. And then those two workloads really help build these AI capabilities, and that's across a wide spectrum from text generation all the way to multi-agent systems, which are starting to become much more prevalent, and how we improve sort of that human computer or human machine collaboration. And those capabilities then lend itself to AI applications, which either fall into a category of internal productivity, IT-oriented applications, or your industry-specific applications that you're applying on the business side. And again, that ranges from your standard RAG workloads, intelligent chatbots, to supply chain automation, predictive maintenance types of workloads. Now, where industries, or at least most companies, are predominantly looking at AI is to enable these new types of knowledge workers. That is where most of the organizations get maximum exposure. You maybe have a top 10% that has been applying ML and AI technologies over the good part of the last decade. Those that haven't caught up, that really started since ChatGPT, are focused on enabling these knowledge workers for the enterprise. I'll just briefly dive into kind of what these are. The AI SME is your standard subject matter expert. So if you think of as an employee, right, most companies, you have for particular domains, you have a subject matter expert. Just exactly the same way, except that it's an AI model or bot that is trained on that subject matter data and is able to serve a lot more users than a single human can. You move to that AI assistant, you take that SME model and then augment it with automation capabilities. And that could be integration within existing systems, process orchestration, or external system integration and multi-collaboration enablement. So we talk about sort of multi-agent systems. That is what falls under that AI assistant. Another important sort of delineation is with the SME, it's non-transactional. You're not making any changes to any systems. You're really retrieving information and knowledge. With the assistants, you're actually starting to make change. Part of it is, sort of the assistant terminology is, an AI is assisting you to get some work done, right? Some tasks accomplished, which means an action or transaction is being performed on systems of record. And then the last part is the co-workers. As we mature in our adoption of AI, you start to get into these co-worker models. And the best example there is your code generation tools, where a developer is working in concert with an AI model or a tool to go accomplish a particular task. In that case, whether that being writing new code, writing tests, going and identifying security flaws in the code, whole suite of actions. And that model can be applied for a whole lot of other scenarios. Every industry, legal has its requirements, procurement has its requirements, other business sectors have their own requirements. But the basic essence of it is you have a human in the loop to go accomplish a particular task or activity. So in order to enable these different types of co-workers, there are 3 different workload patterns. If I were to come bottom up, the most common and generally applied is the inferencing layer. So that is basically hosting or running a model or hitting a public model, generating a response, and then using that for whatever functions. And that is applicable, whether it's generative AI workloads or ML workloads. That's where most companies are. You have certain set of use cases in companies that are more advanced and have more accuracy or specialized requirement that the out-of-the-box models don't suffice. So you have to get into a layer of what's called as tuning. So again, different methods are applied for fine-tuning, instruction tuning, or even pre-training existing models. And that layer requires another set of capabilities. At the inferencing layer, in a lot of the scenarios, I don't really need high-powered GPUs, right? Lower tier consumer grade GPUs are more than sufficient. My memory requirements are really going to be more dependent on the use case, but for the most part, a smaller memory requirement is enough. If I were to tie that back to the models, a 7 billion model is more than sufficient for most organizations, or a 13 billion model. Worst case, a 70 billion model. I don't need a 400 billion model. When I get into the tuning layer, you're not building a model from scratch. You're really layering on sort of adaptive layers on an existing model. So I don't need full horsepower there, but I do need more capability and power than an inferencing layer. So there you're starting to look at more mid-tier GPUs. A good sort of ballpark is whenever you need more than 1,000 plus teraflops of performance, that's what's going to be applied for tuning. And then the top layer is really again, a very small fraction of companies are going to be needing it, is training your own models. If you're building your own ML models, yes, then that's a process that you will go through. But for these larger language models and foundation models, that's going to be a smaller set of companies doing that. And the frequency of that as well, right? So the training is going to be infrequent. You're not going to be doing that on a daily basis or every minute or every second basis. It's probably going to be a monthly activity or a quarter activity where you're updating a model with newer information and data. That requires the higher powered GPUs. So why are these important? Because each of these sort of workloads and the solution lifecycle, they have different non-functional requirements and have very different needs from an infrastructure perspective. While I can apply inferencing across the board, right? I can just hit public APIs and I'd be sufficient with that. So using a public cloud or a private cloud, those workloads can also run on the edge. And again, I can use a local model, I can use a smaller model or hit one of the larger models. When we get into the tuning step, then your requirements start to change and your infrastructure requirements are much more. But at the same time, it is not always on. So you have sort of fractional requirements. So those are the considerations that start to build up. And I know this is a bit of a dense slide, but I'll quickly touch on how to approach those different types of workloads and workload patterns, and then map them with platform capabilities. So when we think about hybrid AI or AI in general, there are a few things. So we talked about the inferencing, fine-tuning, and the model training. That's on the y-axis. And then you've got your frameworks, toolkits, and applications that are on the x-axis. Where does this lead us? So you've got these different models or sort of application patterns. You've got your vertically integrated AI applications, example, SaaS AI assistants. So your Salesforce Einstein or a ServiceNow Now Assist, and pretty much every SaaS product out there, if they don't have an AI assistant today, they're going to have that within a year. And in those scenarios, from a user perspective, you don't have much. But if I'm one of those SaaS companies or a provider of the technology, then that layer has to be almost always custom built, right? Because you're vertically integrating. So 9 there is the most demand for the hybrid type of environment, where I might have a very customized environment where I'm training my models and building the solution. And then 1, on the other hand, is when I'm applying that for inferencing. If I sort of flip the switch back into sort of the user mode, on the 1 front, that is where most customers, right? Between the 1, 2, 5, and 4 is where most customers are. And in that case, you're leveraging some existing frameworks. If that's on a hyperscaler, you're leveraging the hyperscaler frameworks, or you're leveraging an open source ecosystem. Now, why is this important? Because a lot of this ties back into sort of enterprise NFRs, cost and performance requirements, and then certain management CIO perspective. So we'll dive into some of those requirements here in a bit. So while we walk through the different types of workload patterns and how do you think about these workloads from a macro perspective, when we think about enterprises, there are some of these additional constraints that come into play. Regulated industries are going to have to work and deal with compliance and regulations requirements. And in certain cases, that could be having air gap environments. And I'll give you a quick example of what air gap means. So if today you're using, say, an OpenAI API, or even through an Azure or an AWS, all those API interactions are API interactions, meaning you have enterprise data that is leaving your enterprise boundaries. Yes, the account structure and everything is enterprise managed accounts, but as soon as you send data to an API, that leaves the enterprise layer. So you're starting to get into multi-tenant usage. And again, there's guarantees that most of these companies don't use that data for training. Certain compliance requirements may mandate that you cannot do that. So what is your optionality at that point, right? So that's the consideration. When we look at the secure and sovereign layers, sovereignty doesn't as much apply here in the US because it's sort of self-sovereign if you think of it. Most of the world's data centers are in the US. So your data, everything resides in the US. So less concern here, but for multinationals where you're doing business in Europe and other regions of the world, that becomes a larger concern and viewpoint. And I'll give you a quick example there as well. So sovereign is not just about, yes, you've got governments that are looking for more sovereign setups, but even standard multinational companies that require to be adherent to, say, the EU AI Act must ensure that data doesn't leave the EU boundaries. When you start to use SaaS assistants and out-of-the-box tools, most of them are not able to guarantee that because in most cases, you're running the workloads across regions. There's no ability to guarantee that a particular data doesn't leave not just organization, right? A country or residency, data residency requirements. So that becomes another key constraint. And then the proximity and being able to operate this on the long run. So having predictable performance for these workloads becomes key. Yes, the cloud makes that much more easier, but as you layer on these additional constraints, how do you ensure that you're still able to manage and deliver that predictable performance, and then are able to manage and operate that in the long run?
Nirmal, can we just take a pause first? I
Yeah,
just want to
sure.
take a break.
Yep.
We're covering some great information for everyone. Please put your questions in the chat. I'm going to try to answer them as quickly as we can, and the ones I can't answer, I'll make sure we tear up to Nirmal. So we want to make this interactive. So back to you, Nirmal,
Absolutely.
and please put your questions in the chat.
Yes. Yep. And I know this is a lot of information, but hopefully this kind of helps you think through the workloads and the AI use cases from a different lens. So a lot of the conversations you've probably been in are about, hey, what are the different types of use cases? Where can I apply AI use cases? That is a lens that the business has to absolutely apply. But when you get to that next layer of I've determined my use cases, how do I go build the solutions? What works best for me? And then how do I get to deploying that? That's really where a lot of these considerations come into play. And again, there is not a silver bullet here, right? So every organization is kind of having to go through the process, understand their requirements, understand their constraints, and then take sort of the right approach and determine if a workload is ideal for, say, a hybrid cloud deployment, or it works well in a public cloud deployment or in an edge deployment. So those are the determinations that can lead you there. You probably heard this one as well, right? So the cost of these GPUs, they're not cheap, right? So even if I were to apply lower powered GPUs for inferencing, that is still a significant amount of cost. And you do get cost offsets when you're doing sort of multi-tenant or on-demand APIs, right? That cost is then distributed across a whole bunch of users of the platform, and you do get benefits there. But that's only one layer of costs. As you think about it, there's additional layers of cost. There's, I think, the cost for actual LLM, the cloud platforms and the tool sets that come with it. If you're doing any fine tuning or training, then costs associated with that, which again is not an ongoing cost, it is on as needed basis. And then you have your core infrastructure, right? Cloud infrastructure, again, independent, irrespective of whether that's a public cloud, private cloud, or a hybrid cloud environment. So all of those costs are there. And then the other component to think about is as companies start to scale the use of AI, you have to also start to look at what does that cost account for on a per user basis? And what the chart on the right shows you is an example comparison of your standard sort of co-pilots and enterprise chat GPT as an example, right? Where it's a cost per user per month. And it's more or less a fixed linear cost. Sure, you'll have discounts and then you'll have tiering as your number of users layer over. But if you normalize that across a year, you have 6,000 users, 10,000 internal employees, your cost is normalized into a per employee cost. Now, when you go build your own solution, that's what that black line represents. The pink and the teal lines, they are examples of two different application workloads. And where this really comes into play is some of those general purpose tools are Swiss Army knives. So they let you solve most general purpose things, but most businesses don't need general purpose solutions. They need targeted solutions for the business that is going to help either the employees drive business productivity or gain economies of scale for the business. So when you start to look at those layers, then when you go build a custom solution or build a tailored solution, your cost per user drastically comes down because you're not building a general purpose tool. You're building for a specific business problem. And even if you have a few of those business solutions, your cost per user does come down as you move to that right, the number of users. And that's an important consideration. So when you go down that path, then your choice is on the workload types, the infrastructure, all of those come into bear because you're not just getting something out of the box and all you're doing is just hitting an API. So that's the other piece to consider. Now, the challenging part for CIOs is you want to have that comprehensive strategy that accounts for a bunch of different things. One is a strategic and operational risk. Like all the technologies before, there's always vendor lock-in, there's proprietary that comes into play. So how do you ensure or prevent lock-ins so that you can ensure some business resiliency? So having that optionality view is important. The AI technology is evolving so rapidly. And within a year or two, you're going to see, even today, you're seeing much more mass adoption. It's just going to become much more common in 2 years. So what does that change? We started with traditional ML workloads, moved into the world of generative AI and having much more of these intelligent bots. We're getting into that agentic world where you're having sort of multiple AI systems interact with each other. Think of them as sort of forming their own APIs on the fly and being able to communicate and share information. So as those technologies mature, how we operate and manage that solution also becomes different. So important to ensure that you can continue to sustain that for the long term. As you bring in more workloads, having that predictable level of costs and having fine-grained controls so you can most optimize whether it's your infrastructure applications for the best use for the business. Securing, we talked about security and privacy. That's always a top of mind concern. And then how do you gap the divide between the technical skills and business skills, right? So bridging that so you can start to support these AI solutions at scale, because AI is no longer just for the technical crowd, right? It's for everybody to use. So how do you ensure and sort of bridge that gap? And then this is something that is going to be there for the long term. So it's not a one said and done thing. You're going to have to operate this on a daily basis. And this is a technology that is going to continue to evolve. So as an organization, it is really incumbent that you also evolve as the technology changes and matures. So really, where does this get us is how do I look at my AI architecture and platform that allows me to satisfy all of those requirements, the different types of workloads, my constraints from an enterprise perspective, constraints as a CIO. So really balancing all of that And this is a view that really sort of breaks down each of those layers into much more sort of manageable chunks, but gives you a good, clear picture of the different components that come into play in building and deploying AI solutions. The first consideration, obviously, is what is my platform, right? Where can I securely run my AI workloads? And we talked about different training, fine-tuning, and inferencing capabilities. And then customers also have experimentation sandboxes. So that's a layer where you can apply either a public cloud solution, right? So for those of you familiar with an Azure AI ecosystem or Amazon Bedrock or Google Vertex AI, IBM's got its Watson systems. Everybody's got a layer of capability on the platform side. And then you've also got open source systems that you can deploy anywhere. So I can build this system, again, depending on your requirements, different components might come into play, but you're able to have a much more opinionated stack that you can take and deploy anywhere as the need dictates. You then got to account for the supply chain of AI, and those are a few things. The first foremost is data. So ensuring that you have the right data to as input into your workloads, and in certain case, output of AI models and decisioning that also goes back into the platform. In order to encode that knowledge for some of these AI systems, I need a knowledge graph or a vector store. Most common patterns is having a vector store to embed my knowledge as part of the retrieval augmented generation pattern. Increasingly common and popular is the knowledge graphs, where I'm not just looking at unstructured data that I'm vectorizing, but I'm also looking at how can I better organize my information so I can create that connected graph of knowledge. Really, where a lot of that is headed towards is, like it or not, 5 years down the lane, AI is going to be doing most of that work, interconnecting data, doing the integrations and the exchanges within an organization. So how do you start to prepare for that? That's really where the knowledge graphs come into play. And then in order to have those systems built, you need supporting tool sets. I need a model hub where I can maintain and manage my models, whether that's an out-of-the-box model or a fine-tuned or a pre-trained model, and then frameworks to build these solutions. In certain cases, you're going to have out-of-the-box products that satisfy that layer. So well and good, right? So leverage those, and then you start to build your workloads on top. The solutions are, again, whether it's a generative solution or a predictive-based solution, there's going to be different types of application patterns and UI patterns that come into play. So that is much more inherent within the organization. And in order to enable that, you need a layer, what we call as that enterprise AI framework layer of determining the right architecture patterns, whether that's workflows, agents, what guardrails I need to apply. And if I'm doing fine tuning, how do I integrate that with my overall process? Prompt engineering, model optimization are other key components in ensuring that you have a solution that is much more tailored for your need. Now, the question is, where does this apply from a hybrid cloud perspective? We briefly touched on sort of lock-ins into certain models or certain components. When we think about those workloads, if a hybrid pattern applies more, then having an opinionated stack that I can take and deploy anywhere becomes critical. If this is that opinionated stack, then this allows me, again, given most our open source ecosystems, package them and deploy them anywhere. It'll satisfy all my enterprise constraints of sovereignty, AGAP environments. And you can still run this within a cloud provider and still ensure sovereignty. Because at the layer of infrastructure, everyone can maintain sovereignty. It is when you get to that application layer where the data moves in a multi-tenant manner, again, your SaaS assistants and your copilots, that is where it becomes much more harder to segregate the sovereignty and compliance requirements. So that's, again, another layer of information there. But this gives you a view of how do you approach this problem, and what are the ways forward? So OpenStack is one approach. An open source stack of components is one approach. You can also take this from a proprietary perspective where you have packaged products that can be deployed anywhere. So that gives you a little more optionality at that infrastructure layer. And then a lot of customers and needs also dictate towards build your own, which in a large case tends to be open source based. Ben, any questions while I'm going through?
No, I think you are just wowing them with this level of information. But I don't believe that. I think there's lots of questions, but I think we just need someone to put a question in there, and that'll start the floodgate. Is my thinking
Yeah,
on this one.
absolutely. Yep.
Yeah. So I've got a question.
Yeah, go for it.
So as you're talking to our clients that we're implementing these kind of solutions and these architectures, what have you seen as some of the biggest kind of like, oh, I didn't know that, I need to think about this? What kind of things are uncovered? Because I mean, there's a lot of YouTube, there's a lot of information about how to do this, right? And there's lots of consulting I can. I'm just curious, what are the biggest sort of things you're seeing as you get into some of these detailed conversations?
Absolutely. The stack kind of attempts to address some of that. So I think platform, everybody's aware, okay, I need a platform to run this. How do I get data to my models? The common mechanisms everybody's aware of. The more evolving mechanisms not everybody's aware of, right? Knowledge graph is a good example. Yes, I kind of know what it is, but how do I really accomplish that, right, from an AI perspective? Because most people hadn't moved into graph technology yet. So that's multiple steps of sort of jumping in there. And then often tying that back into where do I really need to go apply that, right? And what cases I don't need it. That's an area that is less explored, I'd say, right, from customer perspective. At this point, again, prompting RAG architectures have become very common. What's not common is more of the agentic based approaches, right? So how does that figure in, right? Is it RAG? Does it replace RAG? So those are kind of the questions. I'd say it doesn't replace RAG, right? It extends that. RAG as a pattern, I think, is there to stay. But how do I extend that to have multi-system integrations in order to go accomplish that? And so that's, again, because a lot of those are evolving patterns, right? So customers not really thinking too far ahead into the future, right? They're thinking about the here and the now, or even maybe a couple of years back. So that's another area that comes into play, where most customers are not yet fully focused on is day two, right? That right vertical pillar in there,
the run side of
business.
things.
Exactly. How do I manage that life cycle? And that is where a lot of challenges arise. Again, I've got to maintain my flow of data, maintain the quality of my data, provenance of data. All of those are going to be important. So that's one layer. That one, I'd say most customers are familiar, right? People have been building warehouses, data lakes, lake houses for a while now. So that concept is much more familiar. But the unfamiliarity part is all of that was in structured data. Now I have to deal with unstructured data. So I cannot necessarily apply the same processes and mechanisms as my structured data. So how do I evolve that to also support unstructured? So that's that divide.
Okay,
right?
Got
that needs to be bridged.
We do have one question from David. What is your experience with customers on AI penetration across the big three, AWS, Azure, GCP? What are you seeing industry-wise, Nirmal?
If I were to put a timeline on it, so I'd say good part of the later part of last decade, you had Google leading the pack. Right? So we did see more customers leverage Google, and the reason they went to Google was because of the AI capabilities. And obviously, Google was a leader; they still are a leader. And I think coming into say 22, right, where sort of OpenAI came into the fold, and the Microsoft partnership, that was a really smart move on Microsoft's front. So you started seeing much more sort of flooding of users adopting the Azure platform. And also because Microsoft quickly extended that into their ecosystem of products, their productivity tool sets, their CRM, what they call as their Power Platform or Power Cloud. And so they've incorporated AI into basically all of their tool sets, Windows as well, right? You see Copilot for Windows. So
Mm-hmm.
you're having much more broader adoption there. It's not just your enterprise infrastructure, right? They're hitting the whole stack. And then you have AWS that, yes, they were a little bit behind, but they've caught up pretty quickly. And they have more optionality on the tool sets. And again, a lot of that goes into the way AWS operates, right? Really getting customer feedback, incorporating that and making that easier, and also providing that sort of builder's toolkit. So they're working sort of within their strengths. So at this point, I'd say it's basically is it a cat's race or a rat's race, right? It's one of those. Every 2 months, you're going to get, or every 3 months, you're going to see each of these platforms better the other one, right? You'll see a lot of benchmarks coming out. And really, user adoption wise, I see 2 or 3 critical things. One is the quality of the models that are available along with the model choice. So that is a key determinant for a lot of customers because, again, the truth of the matter is I can do a lot more faster with a better model, but a better model only goes to a certain extent, right? The general purpose models. The second component is how do you simplify that life cycle of both development and management? That one I
Mm-hmm.
say is a much more level playing field, right? All of them have equal, again, kind of one more than the other. But if I were to just stack rank what's the more popular one, obviously with
Mm-hmm.
OpenAI and Azure adopting OpenAI, that becomes the more popular one, followed closely by GCP and AWS, right? Each of them have their own strengths, and they rely on that strength. GCP has their own native model, while Amazon has their own native model. They are much more reliant on their partners, right? A Cohere or an Anthropic, for example, with the cloud models. So all of them are relying on their strengths, and then where they have gaps in strengths, they're leveraging partners to go fill in the gaps. So each of them are taking a little bit of different approach. With Microsoft, you have, like I said, the product suite and other ecosystem components. Azure, so AWS, that's not the case, right? AWS is focusing on IT because cloud is predominant for them. So infrastructure management, code automation, right? They do a much better job in there. And then Google, on the other hand, yes, there is some consumer integration, but integrating into their products from a search perspective and uh, customer data management, just CDP platforms, Google does a much better job and has more tools in that realm. So it's really starting to become a much more fair sort of competition and battle as we move forward. And at this point, I think all of them are on a same leveling field. It really comes down to who's going to put more money behind it and who's going to go make this much more easier to use.
Yeah, I think, I think from what I've talked to CIOs, I think it's fair to say that the technology layer is going to be equivalent. If it's just going to be, little puts and takes, but it's generally equivalent. It's really then becomes more a sort of like your resourcing strategy. What do you need to know? Who needs to know it? And sort of like your and how you architect for flexibility, and what are the core systems that you're not going to change anyhow, right? There are certain architectures you're not going to change, and so you're essentially stuck in one ecosystem unless you change your core architecture. Is generally going to be, and so I think when we think about this, it's, what we've seen is the most successful ones really start thinking about what is their sort of like run strategy and what do they need to own and not own, they work with some kind of consultant or someone for their first implementation, and then they figure out what, you know, then they work with that third party to help keep up with all the things happening out there, because it's really hard for a single organization to keep up with all the optionality that they may have.
Yep. And I think that
Okay.
also kind of goes back into why hybrid AI, right? Is it gives you that optionality, and you're not necessarily locking yourself in. And you can think of
Right.
the sort of the hybrid pattern in multiple layers, right? I can look at the platform layer, but really where I'd put more focus is that enterprise AI framework and the solution layer. How do you ensure I can take that and run them anywhere, right? If I can switch some of the components below, right, if needed. I
That's right.
think that's really where you want to think about. A good analogy from an infrastructure perspective is uh, containerize your solutions as opposed to going serverless, right? With serverless, I'm basically stuck with whatever serverless technology I have, and any move is a rewrite. With containers, I can easily take them and deploy them on top of any platform, right? Sure, there's going to be a little bit of migration, but far less than having to rewrite entire code bases. So that's, you should apply the same sort of mindset or mentality into this.
Gotcha. Now, Nirmal, I know you've got a couple more slides you've got to get through, so I'm cognizant of making sure we cover the content.
Absolutely. Yeah. So I might just go through a couple more, right? So again, we talked about air gap environment. What does that truly mean, right? So running the foundational model within your enterprise tenancy, that's really what that means. The data not leaving your enterprise boundaries through an API. And when I look at my sort of deployment patterns and what component can run where, right? We've got those three sort of layers, right? A public cloud, and then private cloud is on-prem, anything, any data center that you own, or with another provider, right? But not in a multi-tenant environment. So multi-tenant environment, single-tenant environment, and then you have edge-based systems. And then so it gives you a view of what things I'd run on the edge, what things I'd not do on the edge, right? You're definitely not going to bring your enterprise data into the edge. Most cases with edge, you're dealing with data that's on the edge, and you're not going to be fine-tuning models. And most cases for edge, I may not rely on a model that's hosted elsewhere, right? So I'm looking at a smaller model that is running within my edge systems. So this is kind of what that could look like. And we talked about all these platforms and services. This is a good sort of comparative chart of those different layers, right? Again, everybody has an equivalent service or provider. I've got a kind of view of the hybrid AI stack, again, primarily open source based. So that's something that you can take and apply on any of the hyperscalers as well. But as you see this, everybody's got more or less a level playing field today if they didn't have it last year, right? And then going to the next year, 2 years, it's just going to become much more level playing field. At which point, really the differentiation is going to be on you, right? How are you going to drive value for the business? And where do you see opportunities to transform the business with AI? And with that, I just want to show a quick view of what that general inferencing architecture can look like. Again, the reason we call this hybrid is you can take this model and apply it anywhere. We've talked about that platform. So in order to have true hybrid AI inferencing architecture, you need a platform where I can run any container-based workloads. Right? So that becomes sort of the common denominator. Some form of scheduling those workloads. Again, most container-based container management systems do have workload scheduling incorporated as part of that, a way to manage my registry and containers and images and things like that. The model hub becomes an important piece. So whether that's enterprise models that you built, how do I manage that within the enterprise? Or I'm using certain open source systems, again, Hugging Face being the most sort of predominant hosting provider for open source models. How do I take those open source models, package and deploy, right? That's a layer that comes into play. How do I provide ongoing management? So whether that's on the LLM side or on the AI observability side, how do I integrate those capabilities? Integration of data becomes another key point, right? So you're connecting to your enterprise data sources. And how do I ingest that data? The whole set of requirements that go into play, right? Handling data quality, classification. Most companies are used to classifying structured data. How do I now apply that to unstructured data? And the generation of information from existing knowledge, right? How do I classify that data? So that becomes another challenge. And then part of this is versioning, bias validation. The list goes on, right? There's a lot of inputs that needs to go into that data ingestion piece. You've got models to manage that integration. And again, whether it's a graph or vector database, how do I store that information to be leveraged by a model? And then that middle layer is where sort of you put the meat on the bone, right? Is I've got my foundational model. If it's an open source model, how do I package that and deploy that? So that's considerations that most customers, most people don't put into stock because you have, I mean, OpenAI has really made that easy, and other providers as well, right? I just have an API to get to the model. But now packaging comes into consideration. And then the rest is the framework, right? So how do I build agentic workflows? What are the primitive application primitives that I need to incorporate? And then how do I interface that with the rest of the ecosystem, right? Most of these AI solutions are not just going to be one-offs. That's where we started with, right? With chatbots and so these one-off solutions that are outside of your normal day-to-day working systems, working environments. It is going to get much more embedded and incorporated into everything that you do. So the application integration becomes a key point. But again, going back to the point that in order to ensure you can meet all the constraints requirements, looking at a more hybrid type of environment then becomes key and gives you a lot more control going into the next 2 years, 5 years, even 10 years.
Yeah. Nirmal, we had two questions here. One from Daniel. Do we use causal AI to understand cause and effect relationship beyond identifying patterns and correlations, aiming to understand why things happen?
I've not seen much of that, to be honest, with customers. To me, I think that is one that comes with maturity. The more basic problems that customers are trying to solve at this point, then starting to get into that sort of causal nature of why certain things, and then kind of what was that determination. Right now, where we see a lot of that falls under that sort of evaluation bucket of trying to understand how that information was built out, right? Or why a particular sort of response, if I take GenAI as a play, right, was generated, or even if it's traditional models, you're doing that level of traceability. And I think the next layer from there is that causal nature, right? Is you're trying to determine the patterns of why you actually got that.
Yeah. I have one other question from Gary. Any best practices for clients wanting to maintain optionality, agility, and manageability per a prior slide? What are parallel lessons learned here from cloud adoption, right? Cloud, everyone jumped into it. You got stuck by vendor lock-in. You start having huge costs. So what are some of the lessons learned? And was that just a setup for this slide?
That was very cool.
Okay.
That was my final slide, right? So thanks for the question, Gary. I think the key things, right? The industry is moving so fast, and the technologies and the models are evolving rapidly. So I think one lesson, if I take at the model layer, models have become commodity, right? So I think that's the first thing. Earlier on, it was like, hey, I need the biggest and the best model. Not the case anymore, right? In most cases, you don't need the biggest and the best model. You need something that's more aligned for your business needs. So that's one of the important lessons learned. And again, that's where the open piece comes into play, right? Am I better off using open LLMs or proprietary LLMs? In conjunction with that, why is that the case? Yes, cost, size, those do matter, but regulations and um, understanding lineage. Most of these proprietary models, we don't know what data it's trained on, right? And you're applying that for enterprise purposes. And that doesn't work well for certain industries where you want traceability and auditability of, and I think somewhat ties back to the causality question that came in before, right? In determining how you got there, proprietary systems don't work well in that case, right? So having an open source model is important, but it's not just open source, right? I'll give you an example there as well. Llama is a great example. Llama is an open source model, but it's a proprietary model in the sense that we don't know what data it's trained on, right? Meta is doing that, and they're releasing the model to use as open source. So yes, it's cutting off one layer, but not the other layers. And then there are truly open source models. Bloom is a good example of that, where all the data used to train that model is documented and made available in open. That is truly open. So you got that wide spectrum. And the key lesson there is like really understand your enterprise requirements and then adopt and choose the right model that works for the need. The other one is everybody was from a POC perspective, right? They just wanted to go use what's readily available, what's the best out there. Everybody wanted to hit an OpenAI API and just use that for all business purposes. Once you peel the layer and look at organization, regulatory, country requirements, that doesn't fit the bill for most. So that's the other important lesson, right? Is 80% of the POCs are going to go nowhere because of those requirements. And now people are starting to realize, okay, I can't do X, Y, Z. How do I augment for that, right? How do I build capabilities so I can satisfy regulatory requirements, but also business needs and requirements, right? So that's the other piece that's starting to emerge, right? Just from what we're seeing with lessons learned with customers.
Yeah. Hey, Nirmal, before you close up, because we've got 2 minutes left, I will ask folks on a scale of 1 to 5, 5 being valuable, 1 like I could have done this on YouTube. Could you just give us a sense, kind of like what you thought about this webinar in the chat, please?
Yeah, perfect. So yeah, thanks, man. I think that's really all I had to again get into a lot more details. Happy to connect with folks in the Ohio region. That's my LinkedIn out there, and Ben's a local, so a lot of you interact with Ben. But thanks for your time, and Ben, any last thoughts from you?
No. If we can help you in any way, please let us know. I'm easy to find, and Nirmal is easy to find as well. So we'd be happy to help think you through making this getting AI at scale successful in your org.